All right, so now what we're going to do is we're going to use the definition of the derivative. So remember, anytime you hear the term derivative, you have to think instantaneous rate of change or instantaneous slope. You're finding the slope in one particular spot on your graph, okay? One instance. So for instance, if you're a business owner and you want to know how much did your profit change in week 3, well, using the definition of the derivative, you can find the instantaneous profit change, right? Because when you're looking for a derivative, you're looking for a slope. So the slope or the rate of change happens at that particular point. So it's a very powerful tool. So let me just help you with this too. So remember the limit. The limit talks about as things are approaching. We don't care what happens at the value. We want to know where is our value approaching. So this idea of h is approaching 0, remember this is a fraction. You can't have 0 in the bottom. But we can approach 0. We can get really, really, really close to 0. So we can get 0.000001 away from 0. It's not 0, but it's very, very close. So it gives us a very specific answer and a very specific value as h approaches 0. Okay, it's not 0, it's just approaching 0. So let me write the function, and it's called a 4-step process. So here's our function, f of x equals 2x squared minus 5x plus 3. Okay, so this is our parabola. Okay, so where we're going with this is we're going to be able to pinpoint our slope anywhere on our graph. So if you remember, a parabola looks something like this, right? Well, over here, my slope is negative. Then it hits a point where my slope is 0, and then it changes to positive. Well, I have a negative slope here, I have a positive slope here. Using the definition of the derivative, I can find the slope anywhere on my graph. So it's all about algebra. Being able to algebraically set this up is very important. You have to have very strong algebra skills. So what this says is take out my x and plug in x plus h. So that's what I'm going to do. I'm going to take out my x and plug in x plus h. Okay, I need to give myself some more room over here. Hang on. All right, so let me start over. I'm going to take out my x and plug in x plus h. Okay, that's the first step. All right, so let's go ahead and do this. So this is step 1. X plus h squared. So remember FOIL? This is x plus h times x plus h. So x times x is x squared. X times h is xh. H times x is another xh. And h times h is h squared. So I'm going to add my like terms. So I have x squared plus 2xh plus h squared. Now, you're going to see this a lot. This is something that's going to show up a lot. So you can save all of this just by memorizing this trinomial. Okay? So let me write it over here on the side so we won't forget it. I'll write it up here. So x plus h squared always equals x squared plus 2xh plus h squared. And if you don't trust me, go ahead and work it out. Okay, so here we go. So I have 2 times x squared plus 2xh plus h squared. And then I'm going to distribute this 5 through plus 3. Okay, now last step, I'm just going to distribute this 2 through. So I get 2x squared plus 4xh plus 2h squared. And then I'm just going to finish writing. Okay, so this is this first step. That's all I've done. Okay, again, algebra. It's being able to keep track of my signs, keep track of my like terms, and so on. Now, this says subtract off my function. So I'm going to subtract off my original function. Okay, that's the second step. All right, so notice I put my function in parentheses because I'm subtracting this whole thing, which means I'm going to push this negative through and change all my signs. So that was negative became positive, was positive became negative. Okay, so now I can start canceling. I have a 2x squared and a negative 2x squared. I have a negative 5x and a positive 5x. Anytime I have a negative and a positive of the same thing, they cancel. Positive 3, negative 3. Now, this is the beauty of this definition of a derivative. You're going to be able to do this every single time. Once you are done canceling everything, the only terms you have left will have an h in it. If you ever have a term that doesn't have an h in it after you've canceled, you did something wrong. It's usually because you didn't push that negative through all the pieces in the original function. Okay? So now we're done with step 2. Now we're going to divide it by h. Okay? I cannot go through and just cancel the h's. I have to factor an h out. All over h. And now I can cancel. Okay? So that's step 3. So now we're going to apply the limit. So the limit as h goes to 0 of 4x plus 2h minus 5. So here's where we just plug our limit in. Every time I see an h, I'm going to plug it into 0. So when I plug 0 into here, this all becomes 0, so it cancels out. So the limit is 4x minus 5. Now, what did you just find? This is where you have to remember what you're doing. You just found the derivative. What's the derivative? The slope. All right, so let me show you what this means. If you had a function, and let's say we graphed it, and I don't know exactly where this is on our graph, but it's going to be something like this. Okay, I don't know exactly, but it's going to be something like that. I can find the slope anywhere on this graph. If my x is 1, that means I am finding the slope right there. I'm finding that slope. I'm finding that rate of change. So at month 1, what was my rate of change? So I plug it in. 4 times 1 is 4. 4 minus 5 is negative 1. So my graph is not accurate. It needs to be moved over a little bit. Okay. So if I plug in 1, my slope is going to be negative. So that means it's going to be down something like that. If I plug in negative 1, okay, negative 1. 4 times negative 1 is negative 4, minus 5 is negative 9. So at negative 1, it's going to be even steeper. What if I plugged in 2? 4 times 2 is 8. 8 minus 5 is 3, oops, which means my slope changed. Okay, so somewhere between 1 and 2, I had where the slope is 0. So my parabola is going to look something like that. Okay, I don't know where it changed. I haven't found that out yet. All I know is at positive 1, my slope is going downhill. Now, here's an application of this. If I know at month 1 I had a negative profit, right, negative rate of change, month 2 I had a positive rate of change, something happened between month 1 and month 2 for me to be able to identify, oh, At this point, this is what we did, and we got our profit to turn around. We started increasing our profit instead of decreasing our profit. Okay? So for right now, what we're going to do is just concentrate on using the definition of the derivative. The visual is just for you to see what you've done. Okay? See what this means. This is any place on your graph you can find the slope. All right, let's try another one. All right, how about f of x, x squared plus x. And now we're finding the slope or the definition of the derivative at x equals 1. Okay, so we're going to go through that 4-step process again. First step, every time you see an x, you're going to take it out and plug in x plus h. X plus h squared, we already know, is x squared plus 2xh plus h squared, and then plus x plus h. Okay, so now I've done this part. Now I'm going to subtract off my original equation. Okay, which means I have to push this negative through, so this becomes negative and that becomes negative. So now I can start canceling. X squared, negative x squared, positive x, negative x. And all I have left is 2xh plus h squared plus h. So now I'm done with these two, the first two steps. Now I'm going to divide the whole thing by h. I can't just go through and cancel. I have to factor out an h first. All over h. Now I can cancel, right? You can't cancel unless it's showing all multiplication. So now I'm going to apply the limit. The limit as h approaches 0 of 2x plus h plus 1. The h goes to 0, which means that cancels. So I end up with 2x plus 1. This is the definition of the derivative. This is the slope or the rate of change anywhere on that function. Okay, now I wanted to know what's the slope at x equals 1. So here's my slope. All I'm going to do is take out my x, plug in 1, and my slope at x equals 1 is 3. That means it's a positive slope. Okay? All right. How about, let's find the equation. You know what, I'm going to stop there and we'll do another video.